2 to the 3rd squared times 2 to the 7th squared. And then each of these you multiply the power. So this is 2 to the 3 times 2 times 2 to the 7 times 2. 3 times 2 is 6. It's 2 to the 6 times 7 times 2 is 14. And then 2 to the 6 times 2 to the 14, we add the powers, and we end up getting 2 to the 20. Same deal, just, right, different way of getting there. One sec. Come on, mouse. Okay. All right. Let's look at the next one. Keep covering it up with the screen here. Okay, there we go. Next one is, I think, a little bit easier, maybe. Got 5 to the 5th over 5 to the 9th. So one thing I want to point out about this, which I think when we have this over, a few people have a little bit of trouble. If I'm asking you just to write it as base to a power, we really want to write it as 5 to the 5 minus 9, which is 5 to the -4th. You could also write this as 1 over 5 to the 4th, or even multiply that out and say it's 1 over 625. But this is kind of the, I don't know, the nicest way of expressing this, just because it's kind of, it has the least kind of other stuff to deal with. Really, I'm not super worried about which way you would write something like this. And then the last one here. Let's see. X squared times x to the 4th to the 3rd. All over x to the 7th. So again, we're just using the rules. X squared times x to the 4th is x to the 6th, still to the 3rd, over x to the 7th. X to the 6th to the 3rd, we multiply those powers and get x to the 18th divided by x to the 7th. And then we subtract those powers to get x to the 18th minus 7, which is x to the 11th. So those aren't too terrible. All right. Again, please do speak up if you have a question, or let me do more on a certain type of problem. So let's look at problem 9. Solve the following equations either by factoring or by using the quadratic equation. So the first one is x cubed plus 25x plus equal to 10x squared. So as usual, we should bring everything to the left and right, or to one side, and write it in the order of decreasing powers. So I'm going to write this as x cubed minus 10x squared plus 25x equal to 0. And then the first thing I'm going to do is I'm going to look for any greatest common factor. So I can see that each of these have a factor of x. Okay, x times x squared minus 10x plus 25. And at this point, I could, although I'm not going to, I could say this is going to give me x equal to 0 as a solution. And this, I could use the quadratic formula to find the solutions for this part being equal to 0. I'm not, because it factors. If it didn't factor, you could totally say, oh, quadratic formula where a is 1, b is -10, and c is 25. But instead, we're going to factor this, and this factors as x minus 5 times x minus 5. Because minus 5 and minus 5 multiply to positive 25 and add it to -10. And then you could, and when you do, so when you get a repeated factor like this, it really is in your interest to write it like this. Especially if we were graphing this, right? If we leave it like this, you might think that we cross at 5. But if you write it like this, it's more obvious that we bounce at 5 because you have an x minus 5 to an even multiplicity here. So just something to be aware of in a different context. So what do we get? We get that our solutions are x equal to 0, and this part's going to give me x equal to 5. Those are my two solutions for this equation. Do I have a reference for the next one over here? Yeah, sure. The next one is 2x cubed plus 6x equal to 3x squared plus 9. So I'm going to bring everything to whichever side you like. I'm going to pick the side where the highest power has a positive coefficient, so the left. So I'm going to get 2x cubed minus 3x squared plus 6x minus 9 is equal to 0. And then again, we're going to factor. So I factor out, and this time I'm factoring by grouping, right? So I've got 1, 2, 3, 4 terms. That's usually a good sign that factoring by grouping is what the person writing the problem wants you to do. It's not always true, but it's often true. So I factor out an x squared here. I'm left with a 2x minus 3. Let's see, I can factor out a 3 here. I'm left with a 2x minus 3. So I want you to be careful. I feel like a few people will kind of struggle with this next step. The next step, you're factoring out a 2x minus 3 from each of these. So you factor out the 2x minus 3. So you don't have that piece left over anymore. So from here, this part, if you divide this out, you're just left with x squared. From here, if you divide out the 2x minus 3, you're just left with a plus 3. And that's it. And then, just like usual, we set each part equal to 0. So if we set this part equal to 0, we get 2x equal to 3. We get x equal to 3 halves. You don't have to show, you can show less work for that. I'm just showing you the work. Here, if we set this part equal to 0, we actually don't get any solutions. Or I should say we don't get any real solutions. So x squared plus 3 equals 0, x squared equals negative 3. You could stop there and say, oh, no solutions. If you happen to find the imaginary solutions, that is also fine. Someone did do that on either a homework or a previous midterm. It was perfectly okay. But you don't have to find any imaginary solutions. You can always just say there's no real solutions. So the only solution here, actually, so the answer here is the solution is x equal to 3 halves. The only solution, the only real solution for this particular problem. It's funny, one of my coworkers who has a whiteboard in her house, she never flips it over this way. She always turns the whiteboard on its wheels that way because she doesn't have carpet, so it's easier to turn it around. And I would like, it seems totally weird to me that you would turn this thing around. Also, I don't have as much room. She has a little bit of a bigger space than she is teaching in. Okay, come on. So let's do this last one here. 6x squared equal to x plus 2, which is 6x squared minus x minus 2 equal to 0. So we could either use the quadratic formula or try to factor it. And maybe I don't feel like trying to factor it, although I will factor it. But I'm going to go with, I would probably use the quadratic formula here first. So I'm going to say, because it might not even factor, right? It's totally possible you could have a quadratic that doesn't factor and you have to use the quadratic equation. So let's see, this one is going to be a equals 6, b equals negative 1, c equals negative 2. So using the quadratic formula, I'm going to get x equal to negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 6, times c, which is negative 2, all over 2 times 6. So that's going to be 1 plus or minus the square root of 1, and then negative 4 times 6 is negative 24, times negative 2 is positive 48, all over 2. And so then this is going to be 1 plus or minus the square root of 49 is 7. Sorry, all over not 2, 12. So you get 1 plus 7, so 8 over 12, or 1 minus 7, which is negative 6 over 12. And that reduces to 2/3 or negative 1/2. Seeing that the answers were in fact rational, or fractions you prefer, means we could have factored it. I don't care which way you get the answers, but I just want to point out that we could have done it a different way. If our answers had been like 1 plus or minus the square root of 7 over 3, then we couldn't have factored it, right? It doesn't factor if it doesn't have a rational answer. This one you could have factored. You could have said a times c is negative 12, and then I want negative 4 and positive 3. Negative 4 and positive 3. Because those multiply to negative 12 and they add up to negative 1. So then I can write this as 6x squared plus 3x minus 4x minus 2 equal to 0. And then factor by grouping. Factor out a 3x from here. You're left with a 2x plus 1. Factor out a negative 2 from here, and you're left with a 2x plus 1. Again, these have to be the same. Then factor out the thing that's the same. It's 2x plus 1. You're left with a 3x minus 2. And then if we set each of these equal to 0, this is going to give me x equal to negative 1/2. This is going to give me x equal to positive 2/3. So either way you do it will get you the right answer. It's just that, and I think on the test, on the actual test, I did give you a quadratic that doesn't factor, so you have to use the quadratic formula. Just so you know. All right. Now what's next? What is next? Oh, more equations. Solving some equations that are quadratic forms. Okay, so here's one of them. X to the 4th minus 7x squared plus 12 is equal to 0. So here, I think we can just factor this one straight away. Where I'm looking for numbers that multiply to 12 and add to negative 7. That's going to be negative 3 and negative 4. So we really can just see this is going to be x squared minus 3 times x squared minus 4. There are other ways you could do this. You could use the AC method. You could first do a u substitution where you let u equal x squared, and then u squared is x squared squared, which is x to the 4th. And then you could write this as u squared minus 7u plus 12 equal to 0, which then factors as u minus 3 times u minus 4. The only thing I'll warn you about, if you do it this way, right, you still have to solve for x at the end, right? If you just say u equals 3 and u equals 4, you're right, but you're not done, right? Because u is x squared. So then you say, oh, x squared equals 3 and x squared equals 4, which is exactly what we're going to get here. This is going to become, if I'm setting this equal to 0, x squared minus 3 equals 0, x squared equals 3. And same deal here. X squared minus 4 equals 0, x squared equals 4. Let's do the one that seems a little easier at first. If I'm solving x squared equal to 4, what are my solutions? Anybody? Anybody? Is that it? Is there another solution maybe that I'm forgetting about? Like
plus or minus?
Exactly, yeah. When you're solving something like x squared equal to 4, plus or minus 2 is an answer. And really what I'm actually doing is I'm doing x equals plus or minus the square root of 4, which happens to be plus or minus 2. Here it's the same idea, except it's not going to simplify. The answers here are going to be x equal to plus or minus the square root of 3. So I do have 4 distinct answers: positive 2, negative 2, positive root 3, and negative root 3. Any questions about this one? Okay. So let's look at the next one. Also, I think I said on the final, you should double check this, that you don't have to check any of your answers for extraneous solutions for these problems. I definitely would, yeah, I'm sure no. There will be no extraneous solutions for these ones because of the way I've written the problems, right? Some of these types of U substitution or quadratic form problems, sometimes depending on what kind of powers you have to check for extraneous solutions. These problems we do not. So let's do this next one. X to the negative 2/3 plus x to the negative 1/3 minus 6 equals 0. And yeah, I kind of, especially for these ones that have weird powers, I kind of like the factoring by grouping, kind of the AC method, which I guess we could have done here if we really wanted to, right? We could have done, just to show you a different way, we could have done this one as, I'm multiplying to positive 12, and adding to negative 7. So I could have written this as x to the 4th minus 4x squared minus 3x squared plus 12, and then factor by grouping, and got x squared times x squared minus 4 minus 3 times x squared minus 4. And then we got x squared minus 4 times x squared minus 3. I feel like this one, it was easy enough to see how to factor it that you didn't need to do it this way. I guess that's also maybe true here. This part of this one. Sorry, sometimes it's too thick. So maybe you can just see that if you're multiplying the negative 6 and adding it to positive 1, that your numbers are positive 3 and negative 2. So that you want to write this as x to the negative 1/3 plus 3 times x to the negative 1/3 minus 2. Right? That might just be not terrible to see for you. For me, I don't know, for the ones where the powers are weirder like this, it just feels stranger to me. I don't know why, it just does. So if you don't like that, another thing you could do, I mean, instead of just jumping straight to this, you could actually say, well, AC 3 negative 2 multiplied to 1 times negative 6 and add it to positive 1. So I'm going to rewrite this middle term as 3x to the negative 1/3 and then minus 2 x to the negative 1/3 minus 6. From here, I'm factoring out x to the negative 1/3. I'm left with an x to the negative 1/3 plus 3. From here, I'm factoring out a minus 2, and I'm left to an x to the negative 1/3 plus 3. And then I factor out this thing that's the same from each of them, and I get x to the negative 1/3 plus 3 times this minus that. Either way you do it is fine. As long as you can factor it, I don't care really which way you actually factor it. So then we're going to solve this by setting e to be equal to 0. I'm going to erase it here to give myself a little more room. So setting this right equal to 0, x to the negative 1/3 plus 3 equals 0 means I'm getting x to the negative 1/3 equal to negative 3. And then to solve for x, I'm going to raise both sides to the reciprocal power. So I'm going to raise both sides to the negative 3rd power. So I'm going to have, x to the negative 1/3 to the negative 3rd equal to negative 3 to the negative 3rd. power to a power, we multiply the powers, and negative 1/3 times negative 3 is positive 1. So I get x to the first, which is just x, equal to negative 3 to the negative third. I might rewrite this as 1 over negative 3 to the third. So this just becomes x equal to 1 over negative 3 to the third power is negative 27. Or I would write it as negative 1 over 27. And then we do the same thing for this. We would set x to the negative 1/3 minus 2 equals 0. X to the negative 1/3 equals positive 2. Cube, do the negative third power to both sides. X to the negative 1/3 to the negative third is just x to the positive 1. And 2 to the negative third is 1 over 2 to the positive third. So then we get x equal to 1 over 2 cubed is 8. So these are my two answers here. Negative 1/27 and positive 1/8. They're a little funky, but not too bad. Okay, let's see what's next. Okay, last part, some graphing. I try to make the graphs not too awful. Your graphs don't have to look perfect. They just have to have the right points, meaning, right, for aside from the trig graphs, which are earlier in the final, your polynomial graphs and your exponential and logarithmic graphs really just have to have the right intercepts, and if there are asymptotes, the right asymptotes. So let's look at this first one. We're going to graph 4x plus 6y equals to 12. You could solve for y if you wanted to. You do not have to. We recognize that this is a line because both y and x are to the first power. Right? Usually we write it like y equals mx plus b. But as long as you notice that both the power of x and the power of y are 1 and only 1, and there's no other strange powers of x and y, then we have to have something that's a line. So my intercepts I'm going to find the y-intercept by setting x equal to 0. If I set x equal to 0, I get 4 times 0 plus 6 times y equal to 12. 4 times 0 is just 0. So 6y equal to 12, I divide both sides by 6, and you get y equal to 12 over 6, which is 2. So 0, 2 is my y-intercept. X-intercept, I'm going to do the same sort of thing. I'm going to set y equal to 0. Y is 0, this part goes away. So I just get 4x plus 0 equals 12. Divide both sides by 4 to get x equal to 12 fourths, which is 3. So 3, 0 is my x-intercept. And then I just plot those. Actually, really what I do, if I'm not using any grid lines, I just say, well, I know that 3 is bigger than 2, so I should be further over than I am up. So I try and draw something kind of like that, where it looks like this distance is bigger than this distance, but really if it wasn't, that would still be good. And then I just label those points. Or you can try and make your graph look nicer. You can use the grid marks, and you can even use a straight edge, right, to draw your straight line so it looks really nice and straight. Or you can draw a crooked line that just goes through your points. As long as it's not too crooked, it's fine. So lines are like the easiest things to graph. Other things are a little more challenging. What time is it? Okay, yeah, we should be able to get through this. Just speed up a little bit here. So let's see, what do we got next? We have got a quadratic. y equal to negative x squared minus 4x minus 5. So this is a parabola, or the graph is a parabola. And we know it's going to open downwards because of that negative right there. I mean, right, we don't usually, well, it's not that we don't usually look at that, we haven't done that. But it definitely opens downwards. The vertex, so the x coordinate is negative b over 2 times a, so negative 4 over 2 times negative 1, which is 4 over negative 2, which is negative 2. The y coordinate is going to be, so this is where you have to be careful. I've definitely seen a few people get a little mixed up here. It's negative quantity, negative 2 squared, minus 4 times negative 2 minus 5. This simplifies that. So negative 2 squared is positive 4, but then it's a negative of that. So it's actually negative 4. And then minus 4 times minus 2 is plus 8. Remember, when you're finding the y coordinate of a vertex, the first two parts should always be opposite signs. And the second part should always be double the first part. So one of these is always negative and one of these is always positive. If they're both positive or both negative, you've made a mistake. So then we get negative 4 plus 8 is 4. 4 minus 5 is negative 1. My vertex is negative 2, negative 1. My y-intercept is just that number there. Okay, if x is 0, I get 0, 0, minus 5. So now I'm going to graph these things. I'm sorry, not there, there. There's my vertex. And I notice that my vertex here is here, and we're going down, so we're not going to cross the x-axis and have any x-intercepts. So it's going to look like this. Like that. You can mirror this point over here. So here's the way I kind of think about it. And that's negative 2, negative 1. This point's 0, negative 5. From here to here, I went over 1, 2, and down to a height of negative 5. So I'm going to go over 2 in the other direction, which is going to take me to negative 4 and a height of negative 5. You're not required to find this other point, but you're certainly welcome to if you want to. Yeah, I think that's it. So more graphing. What time is it? Yeah, we got plenty of time. I keep losing my stuff. Losing my mind. All right. So next one, y equal to x minus 5 times x plus 1 squared. So the y-intercept, we're going to set x equal to 0. We're going to get y equal to 0 minus 5 times 0 plus 1 squared, which is negative 5 times 1, which is negative 5. For the x-intercepts, we set the whole thing equal to 0. So here we get x equal to 5. It's got a multiplicity of 1, which means we cross. Here we get x equal to negative 1, the multiplicity of 2, which is even, so we bounce. That's pretty much it. So then we'll try and graph the thing. So let's see, I've got a y-intercept of 0, negative 5. Got x-intercepts of positive 5 and negative 1. So here's the way, so I'm going to bounce there. Since I have to go down there, I have to bounce this way. And I'm going to cross here. It looks like I have to do this. That's how that graph would look. As long as your y-intercept is not on the origin, you can usually use your y-intercept to tell how you're oriented compared to this, right? I could not have bounced off this way and still gotten to my y-intercept without having to cross the x-axis an additional time where I don't have an x-intercept. On the other hand, this other problem, I don't think we have that luxury. So let's see here. I keep looking over there. So the next one is y equal to x cubed times x plus 3 squared times x minus 2. So first off, the y-intercept is 0. Because if x is 0, 0 cubed times, I don't care what's left, 0 times anything is 0. So then let's do the x-intercepts. We're setting this whole thing equal to 0. So really we're just setting each factor equal to 0. So we get x equal to 0, which has a multiplicity of 3. So we're going to cross. We have x equal to negative 3, which has a multiplicity of 2. So we're going to bounce. We have x equal to 2, which has a multiplicity of 1. So we're going to cross. So let's see, 0 and negative 3 and positive 2. And this is definitely the time where we need to say, well, I need another point. Or the sign chart would also be fine. I'm just going to pick another point, not one of these intercepts. I'm going to pick x equal to 1. So if x equals 1, y is going to be 1 cubed times 1 plus 3 squared times 1 minus 2. That's going to be 1 times 4 squared times negative 1. I don't actually care what the value is. I just care that it's negative because it's 1 positive, positive, negative. It is negative 16, but I don't need you to graph that super specifically. All that means is I know that my graph is at 1, it's negative 16, or it's negative. So now I know that I'm going to bounce here. I'm going to go through here and through, or sorry, yeah. I'm going to cross here and cross here. So I'm going to cross here, get this point, and then cross again. Maybe it doesn't look like my best graph ever. Oh well. Maybe try and make it look a little smoother. And then I'm going to turn around so I can bounce off here. All right, that's that. I also mentioned the solutions are posted on Canvas in the module. So if you want to look at what I've written, you certainly can. And we'll also get this video posted as soon as I can today in case you want to go back and see things again. Well, let's look at the last question, which is graphing some exponentials and logarithms. So let's graph this one. Y equals 3 to the x plus 2. So that's just going to be shifted up 2. So my new horizontal asymptote, it was y equals 0. Now it's going to be y equals 0 plus 2. So y equals 2. And my new x-intercept, sorry, y-intercept. So the y-intercept, you can actually just literally plug in 0 for x, right? We know it usually is 1, and we shift it up 2, it's going to be 3. But you can also just say, well, I'm going to set x equal to 0, and then y is going to be 3 to the 0 plus 2, which is 1 plus 2, which is 3. And then it has the usual shape. That's it. That's all I need. The other exponential graph that's shifted downwards is a little bit more work. because there is also going to be an x-intercept defined. So y equals 2 to the x minus 4. We're shifting down 4. So the new horizontal asymptote is going to be y equals negative 4. The y-intercept, again, we set x equal to 0. Y is going to be 2 to the 0 minus 4, which is 1 minus 4, is negative 3. And then there's obviously an x-intercept that we should find. So the x-intercept, that's when we set y equal to 0. So if y is 0, we get 0 equal to 2 to the x minus 4. Add the 4 over so that you've got 4 equal to 2 to the x. And then write both sides. I mean, this one you might just be able to see what the solution is. But the way we usually solve these when they're more complicated is you write both sides as powers of the same base. So they're both powers of 2. The right side is 2 to the x. The left side is 2 squared. And once the bases are the same, we can automatically conclude that the powers have to be the same. So my x-intercept is the 0.2, 0. So there's our exponential graph shifting downwards. All right, we got 2 more graphs. Plenty of time. Almost plenty of time. So let's see, the next one is the log base 5 of x minus 3. So this is going to shift it 3 to the right. So the vertical asymptote was x equal to 0, but now is x equal to 0 plus 3. So x equal to 3. My vertical asymptote. And then my x-intercept was x equal to 1, 0, or x equal to 1. Now is going to be 1 plus 3, which is 4. It's usually, for these ones that haven't been stretched kind of weirdly, the intercepts are always just 1 away from the asymptotes, if that makes sense. So this is going to look like that. And if you want to check that, you can. You can plug back in 4. And if you plug in 4 for x, log base 5 of 4 minus 3 is equal to log base 5 of 1. But log base 5 of 1 is just asking the question, 5 to what power equals 1? And we know 5 to the 0th power equals 1. So the y value is 0 when the x value is 4. So the x-intercept is 4, 0. Okay, one more. So now we're going to shift the logarithm to the left. So what do we got here? I've got, where'd you go? Log base 16 of x plus 4. So that's going to shift us 4 to the left. So the vertical asymptote is going to be 0 minus 4. So negative 4. And the x-intercept is going to be 1 minus 4, which is negative 3. Again, you can check. If you plug in negative 3 plus 4 is 1, and log base 16 of 1 is 0. So when x is negative 3, y is 0, which means it's an x-intercept. Here's x equal to negative 4. There's the vertical asymptote x equal to negative 4. And here is my, ooh, that's not my best. This shouldn't curve back like that. It should just look like it's getting closer and closer to my vertical asymptote. Not my best. I've drawn better. There, that looks better. And then we clearly have a y-intercept. So we should find it by setting x equal to 0. So if x equals 0, y is going to be log base 16 of 0 plus 4, which is just log base 16 of 4. And you might know what power you have to raise 16 to get 4. But if you don't, you can rewrite this equation. You can write this as, oh, this just means this is the same as 16 to the y power equals 4. So then, if I'm solving 16 to the y equals 4, I can rewrite these both as powers of the same base. So 16 is 4 squared, and 4 is just 4 to the first. So I've got 4 squared to the y equals 4 to the first. So I've got 4 to the 2y equals 4 to the first. So 2y equals 1. So I can write this over here, which means y is 1/2. So I know it doesn't look to scale, and that's okay. This point here is 0, 1/2. All right, that's the whole practice file.